What's up, guys? This is LeetCode 443, stringy compression. Given an array of characters compressed in place, the length after compression must always be smaller than or equal to the original array. Every element of the array should be a character, not int, of length 1. After you are done modifying the input array in place, return the new length of the array. Could you solve it using only constant extra space? So there are 3 examples here. Let's see the first one. A becomes A2, B becomes B2, C, C3, and we have to return 6 because it's the length of this array here. Okay, this could be easy if we could use another array, because we could count the number of letters that are the same in the same subsequence, and we could add to this new array the letter and the amount of time that we saw this letter in this subsequence. But we are gonna try to solve this using the same array. So we're gonna try to solve it in place. So if the array has just one letter, we are not gonna modify it. We are just return it. And when we have, this is a good example because here we have a subsequence with one letter that appears more than 9 times. So we have a number with 2 cases here, and we also need to put it in this sequence. Yes. So I think we are gonna need a for loop here to add this number into the sequence. Okay, so I think the solution for this problem, we're gonna need a for loop where here we are gonna check if the current letter is equals to the next letter. If it is, we are gonna increment a count variable, and if it is not, we are gonna enter in another for loop to add the number of times this letter appeared in this sequence. But I think, as example 3 is showing us, if a letter appeared just once, we do not need to add the number 1 in front of this letter. Yes, so we have to check for this case. If the count variable is 1, we are not gonna do anything. We just have to continue into this for loop. Yes, I think this is the solution. Let's try to write some code. So let's start checking if the input is valid. So if chars a length is less than 2, I think we can just return the length of chars. So return chars the length, because here chars will be or 0 or 1. So in both cases, we are gonna return its length. Yes, so here we can start our for loop. First, we are gonna declare some variables. We need the count variable starting with 1, because if we have just one letter, it is 1 time that this letter appears in the sequence. So count variable start with 1. And also we need here our result variable, because we are going to update this variable through the for loop. So the result will start with 0, and we are going to update it through this iteration. So our for var I equals to 0, while I is less than cars dot length I plus plus. And here we can start by checking if the current letter is equals to the next letter. So if cars of I is equals to cars of I plus 1, we can increment count and continue to the next element of this sequence. And here we have to care about out of bound indexes, because as we are checking here I plus 1, when we get to the last element of this sequence, if we proceed with this operation, we are gonna have an exception, because we are gonna try to access an index that is out of bounds. So we can start by checking if I plus 1 is less than cars.length. And that's, I think that's right, because this check will prevent us to get out of bounds. So let's see the example again. I think this will, yes, so by doing this for loop, I think the count variable will give us the amount of time that this letter appears in the subsequence. And now I think we have to start our kind of swaps here, because in this case our result variable will be at the 0 index and the ith index will be at 1. Okay, so I think I will put the ith index at the result index, increment the result index to start to put the amount of times that this letter appears in this subsequence. Yes, so we can do this by cars of result plus plus. So we are gonna first add a letter into this index, and after that the result variable will be incremented. It equals to cars.I. After that we can check if the count variable is greater than 1, because if it is, we are gonna add this count variable as cars into the cars sequence. So let's do this by, we can do a for it into a character of a character into a list of characters. So conjure to a string. And doing that, we can add cars of result plus plus equals to character. And again here, yes, I think here we can also prepare the sequence to the next iteration. So we can add the next letter into the current index, the current result index, because yes, because we have to prepare for the next iteration. And again, we have to check for the last index of the sequence, because we are gonna add the next character into the current index, but we have to check if the next character exists. So if I plus 1 is less than cars.length, we can add cars.result is equals to cars.I plus 1. After we get out of this for loop, we can just return the result variable. And I think if we do not have any typo here, this is the solution. Let's try to run the code. C that does not exist in the current context, line 31, for each var C and count.toString. So why C does not exist here? For each var C in count.toString. Okay, so it's just a typo. I had this semicolon here at the end and it shouldn't be here. So let's try to run the code again. Answer C5. Oh, okay. Okay. I think I know what is this. What is this? Because yes, we have to reset the count variable here. So count is equals to 1 again. Okay, that's it. So let's try some edge cases here, like the example 2. And example 3. Okay, let's try to submit. That's it. So the time complexity for this solution is big O of n, where n is the length of the sequence of curves. And the memory complexity follow-up here is asking us to solve this in constant extra space. But we are not doing that because of this operation here. This operation here will use some amount of memory because we are converting a number into a sequence of characters, and yes, that will use some amount of memory. And yeah, that's it. Thanks for watching.